All right, so today is day 2 on 6-2, and we're going to talk about graphs and how to look at equations, figure out what the graphs looks like at the ends of the graphs, and what your x and y intercepts will be. So get those 5 things put into your calculator. This would be like y1, y2, 3, 4, and 5. Be really careful and make sure that you check those equations accurately. Okay, so once you have them in, for instance, if I turn on the y sub 1 and I hit graph, the graph of that looks like so. And I need you to come up and, or on your paper, write down what the end behavior is and what the the number of x-intercepts and what the end behavior. End behavior just means where does your graph start and where does it end. So if you looked at the ends of your graph, like this one starts in a down position. Notice it's sloped like that, so I slope my line also. And it ends in an up position, up here. So my end behavior is down up. Yes? Okay, you got to talk to me about it in a while. I can't. I'll be walking around. Okay, so we have our end behavior. All right? And then the number of x-intercepts, how many times it crosses the x-axis. Well, this one crosses once. Okay, I want you to do that for each of your graphs now. Nick, if yours aren't graphing, make sure that your equal sign's highlighted. For whichever one. That way you turn them on and off.
Oh, I like them.
All right. Hey, I'm going to go ahead and move on to the second one, y sub 2. I'll turn off the plot, y sub 1, y sub 2. I graph it. When I graph y sub 2, which did not graph, which means I didn't turn it on. There we go. Looks like it crosses the x-axis once, twice. Has an end behavior. It starts at the top, ends at the top. So it has an end behavior of up and up. How many got that? Okay. Next one, for 3. Again, we turn that one off, turn that one on. And once again, it did not turn on. So, okay. Looks like it crosses the x-axis how many times? 3. Has an end behavior. It starts down, ends up, down, up. Okay. Y sub 4, we'll turn off y sub 3. Turn on y sub 4. The graph. How many x-intercepts on 4? Yeah, it's getting tough to see, but 1, 2, 3, 4. 4 of them. Got a W there. Has end behavior. Starts up, ends up. Up, up. Notice the slant on my arrows also. Kind of shows the slant of the graph there. And last one, we will have, turn that one off, turn that one on, and we graph. How many x-intercepts on the last one? 5. X to the 5th had 5 x-intercepts and has end behavior of 1, or up, or down, up. Down and up. All right. Everyone with that?
Yeah, dog.
The fundamental theorem of algebra, we can always estimate the number of possible x-intercepts by looking at what? A couple, talk to your neighbors real quick. Let's see if we can get that. Know the answer?
Yeah.
Okay, so we can always estimate the number of possible x-intercepts by looking at what, Gabby? Yeah, the highest degree of our variable. If the degree is 1, there's one possible x-intercept. Now, with that being said, can anyone think of a linear equation where there is not an x-intercept? Why don't you sketch it on your paper right here, where there's 0 x-intercepts? Okay. Nick? Okay, yeah, you could have y equals 1, right? Not x equals 1. X equals 1 would actually cross at 1. But yeah, if you had a line that ran parallel to the x-axis, a y equals, without an x in there, That's 0 x-intercepts. So you could have 1 or 0. Could you have 2?
No.
Have you ever seen a linear equation with 2 x-intercepts?
Yeah.
You could have infinitely many, right? Okay, but we couldn't have 2. All right. How about an x squared? Could we have 0 x-intercepts on an x squared? Okay, go ahead and sketch on your paper what a 0 x-intercepts on an x squared would look like. Zero x-intercepts. Okay, maybe you sketch something that looked like this. A parabola that doesn't hit the x-axis. Okay, maybe it's going downward, but it's below the x. Could you have 1 x-intercept?
Yeah.
Yeah, you could, right? You could have 1 x-intercept. It would look like, what would it do? Describe to your neighbor or show them what 1 x-intercept would look like with a quadratic. All right, so what's it look like? I keep hearing the word vertex, Jody. Yeah, the vertex touches the x-axis and then it kicks back up. So you could have, on your quadratic, you could have 0 x-intercepts, you could have 1 x-intercept, and you could have 2, right? We know what 2 looks like. We saw it on our graph, but if you need to see it again, 2, crosses twice. Okay? And I guess we could say the same thing on linear, right? If we wanted our 1, if we want to draw a quick picture, there we go. It's not actually a picture of that equation, but there it crosses once. Here it crosses once. Here it crosses twice. Okay? Cubic. A cubic, could we have 0 x-intercepts? If I tell you, now you haven't had a lot of experience with cubics, but if I tell you your end behavior is down up, it means your graph starts down and it ends at the top. Okay? It has an end behavior of down up. Is there any way to have 0 x-intercepts? No. Tell your neighbor what you think. Yes, no, why? Why? Say no. You can't have it. How many say yes? How many don't know? Okay, if my graph starts down and ends up, it starts down here, but it ends up here. Is there any way of not crossing that line? It's not possible, right? You can't go around it. You can't jump over it. Okay? Well, eventually we'll have holes, but okay. Yeah, two-dimensionally. Gabby?
Wait, I'm confused on the first one if it goes up and down. Like the first one denominator goes up and down, but it goes down.
Okay, hold on. Can we go with this one real quick? We'll come back to that. So there's no way of actually not having. Okay, you can't have a linear, it's not a straight line. It's not going sideways. The first one could go sideways. It's a linear equation. Right?
So, but I thought I had to go up and down.
Right. So this one does go up and down. But your study of linear equations, right? You've studied linear for now 2 years at least. Your study of linear equations, this graph actually has an end behavior that looks like this. But you've seen lines that look like that. Okay. That's all I'm saying, is that a linear could have 0 solutions. Okay. It's possible for a first degree polynomial to have 0 solutions. This is an example. You only need one example to show it. Okay? It's possible for them to have 1 solution. A second degree, it's possible to have no solutions. It's possible to have 1 solution. It's possible to have 2. A third degree, however, you haven't studied a lot. And what I'm telling you is a third degree must have this end behavior. So what you're saying is, well, that's not that end behavior. That's true. It doesn't necessarily have to have that end behavior. Okay? This is kind of a special case on it. All right? But generally it's either up, down, or down, up here. Okay? I'm telling you that this third degree has to either be up, down, or down, up. In this case, it's down, up. So therefore, it's going to cross at least once. Now, can anyone figure out a way to make this only cross twice? Actually, can someone show me how it only crosses once? Sketch it on your paper. If you can figure out where it has one x-intercept and even two, do a quick sketch. Well, let's see. Here might be an example of one x-intercept where you start and go up. You change directions and then jet back up. There's one. Okay, we had one yesterday that many of you may have drawn, just kind of a cubic, that goes like this. One x-intercept. We talked about that yesterday. Okay? You could have a situation maybe where with two x-intercepts you go up and you hit, you jump back down, and then you jump back up. There's two. Anyone draw one like that? Okay. That's our two x-intercepts. And then three x-intercepts we've already seen a picture of, but three you could go up, come back down, and then go back up again. I kind of referenced that a bit or real quick yesterday, and I said no, we're not going to go into that. But there we've got it there. Okay. How about a fourth degree? Fourth degree, could you have zero x-intercepts? Yeah, I mean it's an up-up. You're not familiar with them, but it's up-up. It's really like a parabola. Fourth degrees can also, they kind of look like parabolas sometimes. Now the one we saw was a W. That was with 4, right? So if we have our 4 x-intercepts, kind of if I throw that over here, okay, that was our picture that kind of looked like where we came down and jumped up and did that. Okay, so we had our 4. We have a W. But you could have 0. Okay, and I'm going to have to draw that somewhere else, maybe down here. Okay. So if I draw it down here, if I go 0 x-intercepts, it may just look like that. Looks a lot like a parabola. It's not a parabola. It doesn't have the properties of a parabola, which as you study math, as you go more into conic sections, you'll understand what that means a bit more. Okay, but it doesn't have the properties of a parabola really, but it x to the 4th. Okay, we could have one y-intercept just like a parabola. It could just come down and hit, and actually what happens, it comes down and it hits and it flattens out, and then it jumps back up really quick. Could have one x-intercept. You think you could have 2? Yeah, a parabola has 2. Why couldn't you on an x to the 4th? Okay. In fact, all evens you could do that. All right. Could we have 3? Okay, anyone think of a way to have 3? Yeah?
If it was shaped like a W and the little dip in the middle hit the x-axis.
Oh, wow. Look at that. It's pretty impressive. So if it's shaped like a W, so you go down, right? And then you go back up and hit. Is that what you're talking about?
Yeah.
Yeah. So we hit there, and we hit there. Impressive. Yeah. Good. Okay. X to the 5th. Holy moly. X to the 5th. Could you have 0? Why not? Yeah. Yeah, in behavior is down up. So you can't have 0. Okay. Could you have 1? In fact, you can go through, I'm not going to go through all of them because we just are running out of time, but it'd be the same thing as a cubic. You could have the same idea as a cubic. So you could have 1, you could have 2, you could have 3, you could have 4, you could have 5, but you can't have 0 because you're in behavior. Everyone clear on that? So you can't have 0, you could have 1, not y-intercept, 1 x-intercept. You could have 2, you could have 3, you could have 4, and you could have 5. Can't have any more of that. Now, I'm not going to draw the pictures. We're just going to run out of time. Okay. Any questions there? All right, so our goal now is going to be to find those x-intercepts and to find the y-intercepts. So A, B, and C on this page, I want you to first, doing your best, I want you to figure out what the end behavior is on these and what the y-intercepts are. And if you know the x-intercepts, that would be great too. There's only that part of it. All right, so let's go through part A here. Okay? In behavior. Down, up. Everyone agrees it's down, up. Okay. Y-intercept. Y-intercept is when x equals 0. So what is it, Jody? 0. It's when x equals 0. So if I put 0 in here and 0 in here, I'm left with y equals 0. In fact, your y-intercept is always, yeah?
Oh, couldn't it also be 2?
Can't be 2.
When x is 2, y is 0.
Your y-intercept is when x is 0.
Oh, that's right.
Yeah.
Mind. I'm thinking of
Okay. Your y-intercept is always your constant. So what's your y-intercept over here? Negative 4. It's when x is 0. Okay, so on this one, the y-intercept is negative 4. What's your end behavior on this one? Everyone agree it's up, up? Yeah, it's even. Okay, well, let's figure out x-intercepts. So we know we can solve quadratics by factoring, completing the square, quadratic formula, graphing. This isn't a quadratic, but we can still try to do the first step of factoring. Since, let me rewrite it here, y equals x cubed minus 4x has x in common. We can pull out an x here. When I take out an x times what is x cubed? X squared. And x times what is 4x? Negative 4. Okay, then I know my x-intercept is when y is 0. So if this times this equals 0, well, that equals 0 when x is 0. And this equals 0 when x is, well, x squared minus 4 equals 0. We add 4. X squared equals 4. We take the root. X equals plus minus 2. Make sure you impose. You're imposing a radical, right? So it's positive negative 2. So my solutions are x equals 0 and plus minus 2. So we have our x-intercept, our y-intercept, and our end behavior. Yeah? Y equals x to the 4th plus 3x squared minus 4. Hey, this one's a bit different, right? Because we have this, but we don't have anything back here to pull out. Anytime you look at a problem, you see that this power is half of that, or excuse me, is twice the middle one. We're going to treat it like a quadratic. We're going to write it like this. Y equals x squared to what power? Second power. Now it's a quadratic. Plus 3 times x to the 3x squared, actually. At 3x squared to the first power. You guys with me there?
Yeah.
Okay. Minus 4. All right, make sure your neighbor gets what we just did there. So this is now a quadratic. We can factor it like this. What is my, right here, my variable x squared? I have a 1 out in front. That's my coefficient, right? My x, that usually is here, right? You usually have an x squared. Well, here we have an x squared squared. So rather than x here, we have x squared here. And rather than having an x here, we have a x squared there. Two things that multiply to make negative 4 and add to 3. What are they?
Negative 4 and negative 1.
positive 4, negative 1. You have now factored that. X times x squared times x squared is x to the 4th. X squared times negative 1 is negative 3x squared. Positive 4x squared gives me positive 3x squared. And 4 and negative 1 multiply to make that. If all that equals 0, this becomes x squared plus 4 equals 0. X squared equals negative 4. Am I going to get real answers here? No. Those are going to be imaginary, so I'm done. Those won't cross the x-axis. This right here, x squared minus 1 equals 0. X squared equals 1. X equals plus minus 1, right? You're imposing a root there. Those are my x-intercepts. Tell your neighbor how you would have known right away that these were going to be imaginary and these were going to be real. Well, there's a negative 4 down here and an x squared. How do I know right here that these are going to be imaginary? Yeah?
Because x squared plus 4 can equal less than 1 or less than 4.
Yeah, there's no way to get a number here that's going to be less than 4 without it being negative. If it's a plus here, it's going to give you imaginary. You have an x squared there. All right, we'll come back to ones like that. What do we have here? Up, up, or down, up? Or up, down?
Or both.
It's an odd power. They go in opposite directions, but it's negative a now. So that means it's going to flip them. Yeah, it's going to be up, down. So if they're negative, they just flip over. Y-intercept is? 0. X-intercept?
0.
It's also 0. Yeah, when we make y 0, we solve, that's 0. All right. Questions? Okay. Once you guys try letter D, same thing.